Hello, I'm Dr. Harper. This video is on Operations Management, BANA 3000, section E01. And this is homework number 6, question number 10, which is Johnson's rule. So let's bring up the homework. Now in this homework, what I will plan to do is come down to question number 10. First of all, as I go down to question number 10, also, I've noticed that when I was getting ready for this video, I noticed an old version of this question 1 was out and these numbers were wrong. And so make sure you do look at the actual homework number 6 now for question number 1 here. These are the right numbers. And so I didn't really update this. It got up for somehow it got out before I was able to put the new version in. So make sure you download homework 6 now. Anyway, and so we have the question 1, 2, and then we get into the priority rules, just the definitions here, and also the different rules about the definitions, okay, and what they do. And then down here, and well, first of all, this is just definition of the rules. This is the important points at the end that I mentioned. So it's just comparing the two. And then here I get into the different priority rules. And here finding using the priority rule, what's the first job? Down here, what are the metrics from the diagnostic of flow? And then down here we get the Johnson's rule. And first, question 7 is just the different qualitative questions about Johnson's rule. And down here is actually doing Johnson's rule and what is Johnson's rule. And then finally looking at some diagnostics or metrics of Johnson's rule. Now question 10, this is what we're doing today in this video. And as I mentioned in the lecture, this video I want to go over a problem that's realistic, that's a type of problem that you would encounter, and how you could use this in Excel very quickly, very easily, and come up with a great schedule. Okay, an organization that by the way, this problem here, I modified it, but this is similar to a problem that I actually did in consulting. An organization that continuously processes proposals is addressing a large backlog due to a historical FIFO sequencing. Now, FIFO is the same as first come, first serve. Okay. And so they really, sometimes it's FIFO, some FCFS, it's the same thing. First come, first serve, first in, first out, they mean the same thing. You have been selected, you have been asked to determine a schedule that minimizes the processing time of project proposals through the editing department and the revision department. So there are the two departments. The editing department identifies changes, and the revision department incorporates the changes and produces a final proposal document for release. A proposal must pass through each department. Each department has personnel to service only one document at a time. The editing department is dependent on the type of proposal. The revision time is dependent on the size of the proposal. The time estimates below have been provided to you for scheduling. So there's a number of steps in here. First of all, nowhere in here do I say this is an N by 2 system. Well, you have to recognize it's N by 2. There's one processor, and here's one workstation, and here's the other workstation. Okay, that's first thing. Second thing, to get the minimum processing time, you have to use Johnson's rule, and use Johnson's rule to actually for this problem to resequence these proposals in an order that's Johnson's rule. Well, it'd be really hard to do by hand, but it's very easy to do with Excel. That's what I'm going to be doing. The second thing is how do you do Johnson's rule, and then how do you determine the processing time. So let's do that. And down here are the answers. And when I get done with this, I won't say here's the answer, but I'll show you the answer in the video in Excel, and then you can just compare and get the answer. Okay, so let's do this. let's do this thing. Okay, let's bring it up here like this. Let's take all of these, Control C to copy. Let's bring up Excel. Okay, here's Excel. Open this up. Let's come down a little ways. 1, 2, 3, down here a little bit here. Let's say right here. Control V to paste. Okay, and I'm pasting the numbers. So here is the proposal. Here is the, let me say, Work Center 1, and here is Work Center 2. Okay, make this bigger so you can see what I'm doing here. So I just labeled these here. Okay, so let's just make sure all of these are. Let's format this to Arial because I like Arial. It's a little bigger than Arial is good for Excel as far as the non-serif, but then also the sans serif, the Times New Roman for the homework. Okay, so there it is. Okay, let's do Johnson's rule. Well, the first thing we need to do is to order them, rank order them. Remember, the concept is shorter times on the first server here will be early in the schedule. Shorter times on the second server will be later in the schedule. So I want to order them. Well, first of all, let's get the early versus late. Okay, and the way we would do that simply equals, say, if this time is less than this time, then I'm going to call that E for early, right? Because the shorter times on the first work center should be early in the schedule. Otherwise, I'll call it L for late. So it's an if statement. If D is less than 5, then the next argument, E, is the letter E, which means it's early. And if that's false, the next one is the letter L, which is late. Okay, so let's copy this down all the way down to all 20. And we can see early, late is all over the place, right? So we need to sort this. We want early first and late last. So let's take all of these like this. Okay, and let's come up here to data. Let's see, I think data. And then come over here to sort. So we're just going to sort. It'll do it for us. So the first thing we want to sort by, our data has headers. No, it does not. If we click that, our first row here is not a header information. I just took the data. So now I want column F. So I want to sort on column F, A to Z. Well, E is before L, so it'll sort A to Z. Well, E before L. Okay. But then let me add another level here. Then I want to sort on D. Why? D then is numerical. I want the smallest to largest because I want even though the early ones are first, I want the smallest ones first, and then they can go up. So if I go OK, boom, it changes everything for me. There it is. There's the early, and there's the late down here, and right here it has the smallest to the largest for the early. But notice on here I have the late here all over the place. I want the smallest down here. So let me take all of these late. Let me come back to sort again. Let me delete a level. Now I want to sort on E. Sort on E. But this time I want the largest to smallest because the largest here, I want the smallest down here. So I'm going to click this and say largest to smallest and then say OK, and there it is. And there's my Johnson's rule. So that's how we've done Johnson's rule. And there we go. Okay? Okay, now the next thing is I've already done this in the lecture. I mentioned it, but I'm doing it again. First of all, what is the early finish for the first work center? Well, the earliest time it will finish is just the flow. So that's going to equal the processing time, which is 10, equals the processing time plus the flow of the previous time. I copy that down, and that right there is going to be the actual flow, and that's the time at which the proposal will finish on the first work center. Okay? Let me pull this up here. So, now the next thing I want to do is the early finish on the second work center. Okay? Now to do that, it's going to be similar to the same thing. First of all, this first one, it's going to be the processing time plus when does it start? Well, it starts when the proposal is finished with the first work center plus that. So it'll be 23. But then what about this next one? That's going to equal 16 plus when does it start? Well, it can start when the proposal is finished on the first server, which is time period 24, but also the second work center is still busy until time 23. So what if this 23 was more than 24? Well, it can't process two proposals at the same time. So really, we want the maximum of either the current proposal finished on the first server or the second work center is available. It's the max between those two times. So then I bring that down. When I bring that down, that's the earliest finish of the for the second one. Okay. So now when we see this, let's see, the last job, the last proposal in this schedule is 7, correct? And the early finish in the second work center of that last proposal is 4:55. So that right there will be the total processing time of the schedule. Okay? And I'll let you pick it out. So there's the answer. So notice I'll let you pick the right answer. Okay, but what I want to point out here is how quick that was. Now, question. This was 20 proposals. Would it take any longer to do 50 or 100 or 200 proposals? No, I would just copy things down further. And so notice how quickly Excel can solve all different kinds of problems, unique problems, customized problems, as long as you know what you're doing. And now that we have this, we can also create a Gantt chart. Okay, I won't do that. I did it in the homework, but we can still create a Gantt chart just like I did on the other video. But this is all I have for this video to show you question number 10, homework 6, question number 10, Johnson's rule, and how to do that in Excel. So that's all I have. So between now and the next time I see you, I want to always say to be safe, don't take anything for granted, and be extra safe, stay healthy so you can keep learning. And between now and the next time I see you,